Before you add any liquid ballast to your tractor tire, make sure you have a valve stem suited for use with liquid ballast. Here are 3 common types of valve stems. 1. Large bore liquid valve stems. These are metal and have a removable core that allows for faster filling and uses a mechanical closure to ensure liquid is sealed in. 2. Small bore liquid valve stems. These are metal and have either a removable core or a removable valve core housing if it's a 2-part stem. 2-part stems allow for fast filling due to the large bore opening in the lower portion. Both types provide a mechanical seal. 3. Rubber valve stems. These use glue to seal air in. Over time, any liquid will cause the adhesive to soften and fail, so these should be replaced before proceeding. Next, gather the tools for the job. To complete this work, we recommend a WonderPump and an air compressor to power it, pliers or a multi-tool, safety glasses, a socket wrench with a 5/8 deep well socket, a tire gauge, a core ejector tool or ejector gun, a tire thumper, rim stickers add a nice official touch, and of course we always keep our Rim Guard mug close by for caffeine or hydration. Now let's look at the pump controls. The WonderPump has a few simple controls. An arrow-shaped handle controls the direction of flow through the pump. An air valve acts as an on-off switch for air supply. There are 2 gauges that measure line pressure. One on the pressure regulator, which controls the pump's operating pressure, 20 to 40 psi is recommended, and one that measures the pressure inside the tire. There are also 2 hoses, one that goes from your Rim Guard tank to the pump, and one that connects the pump to your tire using the core ejector tool. Next, place the valve stem at 12 o'clock. To set up the pump, connect the first hose to your Rim Guard tank, ensuring it's locked tight. Then connect that hose to the input on the WonderPump. Next, connect your air source to the WonderPump. Connect the second hose to the WonderPump's output and connect the core ejector tool to the opposite end of that hose. Ensure that the valve stem is seated tightly to the rim by snugging the outer jam nut using your socket wrench. This tractor has a 2-part valve stem, so we loosen the valve core housing slightly using our pliers. Loosen it enough so it's finger tight and holding the air pressure in the tire. Separate the ejector union from the front of the ejector tool's body. Thread the ejector union directly onto the lower half, or large bore, portion of the valve stem. Once the ejector union is secured, you can thread the body of the core ejector tool back onto the union, which is attached to the valve stem. Remove the valve core housing by advancing the plunger forward until it's fully engaged over the valve core housing. Now, turn the hand wheel on the plunger counterclockwise to unscrew the valve core housing. Withdraw the valve core housing back into the body of the core ejector tool. The valve core housing will remain in the body until the fill has been completed. Next, we'll relieve air pressure from the tire, which will allow Rim Guard Beet Juice tire ballast to flow into the tire. With the air supply to the pump turned off, ensure that the valve on the Rim Guard tank is open. Once the tank's open, turn the 4-way valve handle to evacuate to allow air to flow from the tire back into the Rim Guard tank. It is critical to make sure that the tire pressure never falls below 5 psi. Once the tire pressure is appropriately low, change the 4-way valve back to the fill position. Turn on the air supply to the pump to begin filling the tire with ballast. While the tire is filling, you can use your tire thumper to tap the outside of the tire. The difference in sound indicates the level of fullness. As you add ballast, pressure will build inside the tire, and you'll notice the pump's cadence will slow and almost stop. This is a sign that you need to stop the pump and relieve the air pressure. Do this by shutting off the air supply to the pump. Next, move the 4-way valve handle to the reverse evacuate position. With the pump still off, let the pressure inside the tire escape back through the pump and into the supply tank. You'll hear and see turbulence in your supply tank as the air escapes. Use the pump's pressure gauge to monitor the pressure inside the tire, making sure the tire pressure never falls below 5 psi. Once you achieve the desired pressure inside the tire, move the four-way valve handle back to the fill position, and the air flowing from the tire will stop. Depending on the volume of your tire, you may need to relieve pressure more than once. Turn on the air supply to the pump. The pump will have a faster cadence again. Make sure to track the fluid level within the tire. The recommended maximum fill level has been reached when the liquid is up to the valve stem, when the valve stem is at the 12 o'clock position. This maintains an air pocket at the top of the tire, which allows the tire pressure to be adjusted without losing liquid and improves the comfort of ride. Once the tire's filled, shut off the air to the pump. At this time, it may be necessary to relieve any excess liquid and/or air pressure. Remember, we want to keep the liquid below the valve stem level, so you should relieve the air pressure down to the recommended operating pressure. Follow the air pressure relief steps used previously and use the pressure gauge on the pump to monitor pressure inside the tire. When excess liquid and pressure have been relieved, move the four-way valve handle to the fill or neutral position to stop airflow. Reinstall the valve core housing by advancing the plunger forward towards the valve stem until the valve core housing is hand-tight. Withdraw the plunger from the valve core housing. It may be necessary to clear the lines of any excess liquid. We do this by disconnecting the body of the core ejector tool from the ejector union. Before clearing the lines, ensure the air supply to the pump is off. Now move the four-way valve handle to the evacuate position. Turn the air supply to the pump to on. The pump will remove any remaining liquid in the lines back into your supply tank. Once the lines have cleared, stop the air supply to the pump and close the supply tank's valve. Now you can remove the ejector union from the valve stem. Check the tire pressure and adjust it to the recommended operating pressure if needed. Once the proper pressure is achieved, it's helpful to add a quick blast of air into the valve stem to clear any liquid that might remain in the Schrader valve. Finish up by adding a Rim Guard Beet Juice tire ballast sticker to the rim before moving on to the next tire. To ensure a very specific volume is added to each tire, there are two methods to consider: by using the declining or gallons per inch method, or by adding a meter to your pump configuration. First, determine the recommended volume to add to your particular tire. Visit rimguardsolutions.com and use our interactive tire fill tool to find the recommended volume for hundreds of tires. To use the declining method, you'll need to determine the gallons per inch of your particular Rim Guard tank. Next, use that calculation to determine how many inches your tank volume should decline to reach the appropriate volume for your tire. We marked our tank with tape for easy visibility. Alternatively, you can add a meter to measure the flow of liquid between your pump and tire. There are a few considerations for doing this. First, you'll need a method to bypass the meter when relieving excess liquid and pressure from the tire. Ours uses two additional valves that open or close anytime the direction of flow needs to be changed. This prevents potential damage or backflow into the meter. Secondly, make sure you zero out your meter before you begin. Flushing water through your meter when you finish will help keep it clean and reduce the need for recalibration as often. Whichever measuring method you choose, the rest of the process remains the same.